Hello. How you doing?
Hey,
I don't know if you can hear me.
uh, there's a lot of background noise.
I do have a lot of background noise. Unfortunately, but I'm using my phone right now, so did that help? Put a voice cancellation on? Did that help?
What? I can't hear you. What's up?
Okay, you still can't hear me?
Oh, I can hear you now.
Is it better or does it feel bad?
It's better.
Okay, I
Hmm.
have to use that phone. Okay, so how are you doing?
What's up? Hey,
Audio's bad.
what's up?
I guess the audio's so bad.
I could.
Hello, how you doing now?
Yep, I'm good. How are you?
I'm good.
What's new?
Okay, so update.
Mm-hmm.
Look at like the Excel sheet that you have given me.
Mm-hmm.
I don't know if you have it pulled up or do you want me to
I
share my screen?
I have it pulled up.
So the test scores and stuff like that. I was going to like what tutoring, not tutoring, but like office hours, and they was like take an AAMC exam to see where you are, and I took an AAMC exam on Friday last week, not this past weekend, but the weekend before, and got the score that you see that's on there.
Yep. The 484.
And yes, after making like a 490 on like, because I was like, is this an accurate score? Like, is the 490 an accurate score or is this like life hitting me? And then went, turned around, took the AMC and got a 484. So now I don't know what to do. I'm just like
Mm-hmm.
all over.
Got it. Yeah, so the plan was to have you take the Altius exams and then the AMC exams. So yeah, it seems like your first Altius exam score was a 484, and then you got a 490, and then after that, I guess you took the AMC one. So, I still think that we should do the Altius ones before the AMC ones, um, and that by the end of all of this, we can fit in, because I think you had taken the AMC ones before, right?
Yeah, in the past like 2 years ago.
Mm-hmm. Yeah, so that's why I didn't put it in for like the schedule now because
Okay.
yeah, because you took them before, but yeah, I would say to continue with the Altius ones. Um
Okay.
but yeah, the 484 is probably where you're at because that's the score you got on like the first Altius. So the second Altius with the 490 maybe.
But just to like switch, honestly.
Mhm. Yeah. So
So how will my score increase? Just keep taking exams and then just hope it will increase? Because like I'm not seeing evidently after 3 exams we're not seeing any increase.
yeah, so you definitely have to review the exams and make sure that the exam, like whatever topics that the exam tested on that you didn't get or that you didn't understand, you definitely want to like review that topic and do UWorld problems on that subject before you move on to the next full length. So basically after each full length, you want to be doing a full review so you could learn from your mistakes for each exam and then you can apply that knowledge to the next exam.
Okay.
Mhm.
So okay, and then on top of that, I didn't get 10 Altius when I bought it. I only bought 5 at
Oh,
the
that's
time.
fine.
So I'll just like, do you recommend that I just continue reviewing?
Yeah, so how have you been reviewing? Like for instance, the AMC test that you just took. Um, how do you like how have you been reviewing that?
So I ended up getting help from ChatGPT to figure out like what's a better way to like review or make my Excel sheet. And it was basically like I do like a list where I try to figure out why I was getting the question wrong, whether it was content or logic based.
Mm-hmm.
So I switched it up to doing something like that where it was like, okay, I'm looking in to see if it's content or logic based. And then based off of the spreadsheet that we have, like if you go to like the content portions of the Excel, I would do U world questions based off of like the red content
Yep.
of it, like the one that's red. And then the thing is that I'm just going, it's still taking time.
Mm-hmm.
And I don't know why. And this just it's just everything is just it hasn't how do I explain it? It hasn't like picked up, if you get what I'm saying. Like, I haven't seen a progress in the time that it's taking me to like
Yeah. So I
get like sit down and questions done. Like at this point I'm turning on the timer for UWorld, but I think I put it at like 1.5. So it's not like a minute per question, but like it's
yeah.
still like
So I think if you're scoring like in this range that you still have really big content gaps,
uh-huh.
like in the spreadsheet, like for the a lot of like the really basic stuff, like the amino acids, the protein structure, that you still have a hard understanding of it. So I think that you still have a lot of content gaps that are really like fundamental that is prohibiting you from increasing your score. So I think you need to do like a lot of content review. Like for instance, like, you know, I think we talked last time about like making sure that you understand like the atomic like theory, like what's an atom consist of, right?
Yeah.
Having some issues with like protons and neutrons and electrons and stuff, but that's like very
Mhm.
like fundamental. Like you definitely like it's so fundamental that it doesn't even really show up as on the content sheet because it's assumed that you know that. So I think that there's still a lot of content gaps that you have. All right.
Okay. All right.
Yeah. So like going.
So
Yep.
okay, so I really wanted to like see if
Hmm.
doing another exam would be beneficial to me like tomorrow or this week, and it seems like no. I should just like just do like a content review this week
Yeah.
and then think about taking one next week.
Yeah. So like so how have you been reviewing your latest full length, the AMC one that you took?
I told you I did the Excel sheet
Hmm.
where like, oh, do you want to like go through it to look to see how I've done it?
So you're looking at the stuff that you got wrong and then you're looking at what topic that's about and then you look at and then you edit that in the Excel spreadsheet, you're saying?
So no, I'm more looking at it as I'm going through it to
Hmm.
basically looking through everything, like figuring out why it is I got it wrong, like what was it like because like so with some of the questions, it's like I didn't like if I didn't know it, it's something that I could have gotten right because just off of understanding and just logic, like this makes sense. And I wasn't picking those answers, if you get what I'm saying.
Uh-huh.
And then you're getting questions wrong based off of like you're saying like content gap. Like basically content stuff. Like I'm looking at it like, oh yeah, this is something I wasn't able to answer because I didn't know this content portion.
Yeah.
So that's how I'm looking at it. Basically understanding why it is that I'm getting this question wrong.
Okay.
But the thing is that I'm thinking that it's also because I'm not getting in enough questions in per day.
Hmm.
And I don't know if that's also another thing that could be a problem. Like I'm not answering enough questions per day.
Yeah, so I think we could look over the questions that you got wrong in the most recent test to get a good idea of um, what to work on.
Okay. Let me pull up my AMC and then we'll get started on that.
Yeah.
How do you want to do it? You want me to read the passage or
Uh, so let's look at the ones you got wrong.
okay.
Let's see. Here, go back to the previous screen that you were on. I mean, like, hit the done reviewing up on the top right. All right, and yeah, you can hit that. And then in this filter, you can filter for incorrect. I mean, up here. Yeah, go to incorrect, and then hit the purple filter button. Okay. And then review all. All right, so let's see.
Question or passage?
Oh, question. Let's see. Which assumption is being made if the scientists conclude that aspartic acid was formed by the pre-biological synthesis in the passage? Um, okay, so tell me about this problem and passage. Like, tell me what your thought process was and how you went about it.
So my thought process was first biosynthesis. I wasn't So when I was thinking of it and going through the question, I was looking at this and I was like, okay, so all I need to understand to answer this question is that there was ammonia and there was ammonia involved in adding to make aspartic acid, and
Mm.
that's like considered the pre-biological synthesis. But then when I was reviewing it, I realized no, it wasn't that. It was the what was like what are the elements that are already like available primitive earth conditions to be able to like achieve like aspartic acid, if you get what I'm saying,
Uh-huh.
how I looked at it. Yeah. So like That's how I answered the question. That's why I ended up picking D.
Okay. So they said the pre-biological synthesis that they mentioned in the passage. So let me see that. So
Was right here.
yep. So ammonia was thought to be part of the early atmosphere. It was proposed that it reacted with fumaric, maleic, and malic acids to offer a pre-biological synthesis of aspartic acid, which is an amino acid, and then they show it in scheme 2. And then in an attempt to verify this hypothesis, chemists tried to reproduce the synthesis of aspartic acid under simulated primitive Earth conditions, and then they say that they used an open flask containing malic acid was treated with a continuous ammonia feed, and the mixture was heated at 150 for 1.5 hours. Experiment was repeated with a mixture of fumaric laic acids, and then they were analyzing it by paper chromatography. Okay, let me look at the question again. Okay, let's see. Oh, so D is saying that the catalyst of the reaction between ammonia and fumaric acid was with water.
And
Uh,
it wasn't with water, and it wasn't catalyzed.
So if you go up to the top of this passage, yeah, yep. Okay, so this is where they talk about this malic acid being produced via hydrolysis of this intermediate cyanohydrin intermediate. So I think that's the reaction where water is being used, but in the reaction in scheme 2, water is.
Mm-hmm. Not being used.
Mhm. So yeah, so I think this is just a more so a passage error. So yep, so okay.
Understanding the passage.
Hmm.
And then that's another thing. How do I approach the different sections when approaching like the exam? Because one, like you know how people can tell you like, oh, start with the not the passage, but start with like the singular section questions first and then transition to passage,
Uh,
or
y- uh,
or like how do you approach passages? Like what tools and like skills do you use to approach a passage when reading it to like go through it?
yep. So when you're reading the passage, you want to look out for those. I don't know if we talked about buzzwords, but basically words that they expect you to know that are like tied in with the basic sciences. So for instance, like them talking about like a synthesis of a aspartic acid with ammonia, pretty much like the stuff that you highlighted is pretty much the buzzword stuff that you when you read a passage you should recognize and then expect them to ask you questions on it. Uh,
Mhm.
now, I wouldn't recommend like looking at the questions first, when it comes to the passages because the questions tend to be passage based and and you could end up spending more time like if you read the questions first and then you go back to the passage and then look for the answer that way, you can end up spending like more time looking for it. So I think it's always best to read the passage first. And when you read that passage first, you want to be looking out for those buzzwords, which are essentially the ones that you highlighted, and then expect that they'll ask you questions on that.
Okay.
Hmm.
All right. Sounds good. This question. Which of the following statements does not correctly describe dehydration of malic acid to fumaric and malic?
Hmm.
What does not correctly? I didn't believe that we was like um dehydrating tertiary alcohols. The way I looked at it, I didn't look at it and saw tertiary alcohols.
Okay.
And so that's why I put that. And then they said the reaction is stereo specific.
So tell me again about A.
I didn't believe that they were doing the malic acid dehydration based off of tertiary alcohols.
Okay, so I think
And I'm guessing this right here is a tertiary alcohol. No, I thought this was secondary when I looked at it.
uh-huh.
So that's why I picked that one.
Okay. Let's see. The reaction occurs most readily with tertiary alcohols. The reaction involves the loss of a water molecule. Reaction has a carbocation intermediate. The reaction is stereospecific. Um, okay. So we're looking for something that, I guess, yeah, that doesn't describe the dehydration of this. So let's see. Stereospecific versus most readily with tertiary alcohols. Let's see. Okay, so the reaction that's happening is involving the that cyanohydrin intermediate, which is going to be a carbocation intermediate. And
Okay.
yeah, so that would be like an SN1 type of reaction. So when that happens, like so for instance, this is attacking this carbon atom there and
Mhm.
turning that carbonyl into a hydroxyl group. And like I know that they don't like readily like write, or draw the plus charge, but there should be a plus charge there. And so this is overall like an SN1 reaction. So for this question, the uh, choices that we want to keep are the choices that would be consistent with an SN1 reaction. So that would mean like it occurs most readily with tertiary alcohols that it involves a lot. You could have a loss of a water molecule, you could have a carbocation intermediate. All of those are consistent with SN1. Um, but what isn't consistent with SN1 is that it's stereospecific because SN1 reactions can give you the racemic mixture of both like equal amounts of both enantiomers. So for this question, I think it's just um I guess like a combination.
Knowing that this was an SN1 reaction.
Yeah, yeah, because so like another kind of approach that you could have taken here was like if you look at the choices, you can
Mhm.
like which of the choice like so which of the choices can be consistent with one another. So like if it's SN like let's say it's SN2, right? Then
Mhm.
this would be wrong, this would be wrong, right? And you would have like more than one thing that's not right, and that can't be the answer, right? So now
Mhm.
if we look at what's consistent and this is true and then this is true, then we can be like, okay, this is a an SN1 reaction because you're getting in an SN1 reaction, tertiary compounds are preferred and the carbocation intermediate is preferred. Like just those two
Mhm.
ideas, like those two ideas you want to have connected in your head. So, yeah. So I think this is just maybe like a little review of SN1, but also identifying it as an SN1. So, okay. So I would say like this is probably like a combination of like passage information and uh content stuff of SN1 reactions. And
Okay.
let's look at the next one. Okay. So this is a content thing, and
Hmm.
it's kind of an easy.
Yeah, I saw it as soon as I got it. I saw the problem.
Yep. So basically, like it doesn't even matter if it's aspartic acid, right? Like a peptide bond is essentially what they're asking us, and
Yeah.
that would look like this, right? Like it would be a carbon
Yeah.
NH. So yeah, so I think this one's content, but I think you knew it. So
Mm-hmm.
yeah, so I think you're good on that. Oh, okay. So now we have a question, like a passage that's straight up, SN1, SN2, or something like that. Okay, let's see. The solution containing the compound shown in figure 4 is injected into a gas liquid chromatograph. The first peak observed in the GC trace is attributable to which compound? Okay, so this is the content category of separation techniques.
Mm-hmm.
Okay. And so for chromatography,
Mm-hmm.
basically there's a lot of different types, but what you basically are doing in chromatography is you're taking like advantage of like the molecules that you're trying to separate will have different affinities for like the stationary phase compared to the mobile phase. And that's just chromatography in general. Now, gas liquid chromatography is specifically, so basically it involves boiling the mixture, and whichever molecule has like either less intermolecular forces or bonds or a smaller weight, like molecular mass, will be the first
Mm-hmm.
one. Like it'll have the lowest boiling point, and if it has the lowest boiling point, it'll turn into a gas first, and then
So it'll be the first peak.
Mhm.
Okay.
So we want an answer choice that's going to have the lowest boiling point, right? And
Okay.
we know that. So yeah, if you scroll down, so for the ones that end in OL, they're alcohols, right?
Mm-hmm.
And alcohols can produce hydrogen bonds, right?
Mm-hmm.
And
Causing like higher boiling point
yep, yeah,
because they're stronger bonds.
because when you have your intermolecular bonds, which by the way are not the same as like covalent bonds and stuff, right? Like we typically draw
Mm-hmm.
like if I had something like this, we typically draw them with like some type of lines or something that's not like a straight line. But
Mm-hmm.
but yeah, so this is essentially asking you yeah, like in gas liquid chromatography, what's the first peak? So we want to choose the one with the lowest boiling point. So we know that the butanol has an alcohol which can participate in hydrogen bonds, so it's likely going to have relatively high boiling point. And then we have butene, which
It just has a double bond.
correct. And
And then chloro and bromo are higher.
yeah, because these are the halogens, and the halogens can produce since they have more electronegativity, they can
Yeah.
a dipole moment, right? So because
Dipole.
otherwise
Okay.
because otherwise your organic molecules are going to be nonpolar, right?
So they'll elute faster or
Uh
like boil faster. I mean.
Uh-huh, uh-huh. And so,
Sorry.
does it make sense why, like, so, like, if this was just methyl butane, that'll probably have a low boiling point, but the chloro
Mm-hmm.
part makes it polar, right?
Stronger, yeah.
Yeah. So when you think about the types of molecules that'll have stronger intermolecular forces, uh they will involve those halogens because they make the molecule more polar.
Okay. I get that.
Hmm.
This
Okay.
one, okay, I know why I got this one wrong. It's because that it was an SN2 reaction, and when you have an SN2 reaction, you have to deal with the inversion. So it changes from the R that I thought it was to an S,
Yep, yep,
which is why, yeah, so that's why I know that. I understood that.
yep.
Um,
Yeah, it seems like
so what another thing is I don't like that I get the single ones like these.
yeah.
I don't like that I get these wrong. Like, oh, there's not. Well, I got this one. I got these set right, the first
Hmm.
set right, but the other single ones I was getting them wrong, and I did not. I don't like that I do that,
Got it,
but
got
that's just based off of content, I guess.
So yeah, let's see. So far, like it seems like you actually have a pretty good understanding of the content. Like you were able to tell me, you know,
So
yep.
that's the thing that I've been trying to get you to understand. Like I've looked at the content over and over again. My problem is
Hmm.
applying the content I know to the questions.
Yep.
So that's why I'm like, I feel like it's because I'm not answering enough questions a day because it's taking me too long to get through the questions because I'm overthinking it and I don't know how to overcome that. So like I know what the content is,
Hmm.
and so I get frustrated when I'm reviewing it and be like, dang, I knew that. And sometimes I'm like, okay, yeah, I didn't know this definition, this psych definition or something like that. But like, it's, I like the content is there and it's always been there and I've seen it before in like my lifetime because I've been doing this test for 3 years. It's just that I'm not applying it to the question well. And I think it's because like I'm not understanding the question and the answer choices and I'm not overcoming that. It's been
Okay.
a problem over and over again and I don't know how to overcome it.
Okay. Okay. So yeah. So I mean, just in the questions that I've seen so far that you've gotten wrong, like it doesn't seem like it was particularly like a content thing. Um, I don't want to like say that just to like, say it. I just want to like make sure, right? But uh
Yeah.
yeah, so far we've looked at um how the content stuff can be applied to stuff in the passage. So we can work on that. We can work on applying, the content knowledge that you have to the passages and to the questions. But yeah, that's also why I'm kind of asking you like your like thought process as you like so for this question, tell me like um because a lot of times and part of the reason that the MCAT is so difficult is because they don't really ask straightforward questions most of the time. So like even
Yeah.
understanding what they're asking is difficult, right? Uh
Yeah.
so for
Because
this,
I would think it's like a trick question and then whole time it's not a trick question
yeah,
because they ask a question in a way where you think like, this choice is not really the right choice.
yeah, yeah. So okay. So let's look at this one and then tell me like when you read it or even now, like tell me like how you like tell me like I guess in your own words like what do you think they're asking and then what do you think could be um stuff that you think about when you ask that?
hmm So, which of the following will decrease the percent ionization of 1 meter acetic acid? I hate these because I never get them right. Acetic acid,
Mm-hmm.
um, CH3CO2H. So, now I'm thinking like percent ionization. I'm thinking like now I have to do some math when I look at this, and it has to deal with like putting a solution and like diluting it. and then like measuring what's left. That's how I'm looking at it
Okay, okay.
when I look at this question.
Yep.
So evidently that was wrong.
So
And
something that they like to so like okay, we could talk also about like common concepts that they like to test. So
mhm,
this is and so that way when you approach questions, you can kind of anticipate certain things that they like to ask. So what
mhm,
they like to ask a lot about is Le Chatelier's principle. And so this question is asking like that's asking us like what would decrease the percent that this acetic acid gets ionized. So like let's see,
mhm.
right? So the acetic acid looks like this, and when it gets ionized, it
It
loses
looks like that.
a proton, right?
Mhm,
I'll give you this, right?
mhm.
So what I drew here in this forward reaction is the ionization of acetic acid. And
Mhm.
we want to figure out how to make this reaction shift to the left,
Okay.
right?
So that's another thing when I was looking at this question.
Hmm.
I didn't know that that's what they wanted me to do when asking to decrease the percent ionization. Basically decrease the fact that we're looking at basically decrease the fact that we're looking at this portion, like decrease this from happening and to make sure it's basically that is happening. I
Yep.
didn't know that's what the question was asking when it came to that. So that's why I ended up that's why I ended up picking B because when we look at stuff with like 1 molar in a solution
Hmm.
and percent ionization, I'm not looking at like decrease. I wasn't looking at the fact that it was decreasing ionization from like occurring to go to that. But like when reviewing it, I'm like, okay, that's what the question was asking,
Yeah.
and I
Okay.
was
So
supposed
I
to be
think
looking at it. So yeah.
yeah. So I think that's good. So now we know that at least for this question, it's just them asking us weird kind of questions. But if you just think in terms of like what is an acid gonna do? Like what acetic acid, like they're telling us it looks like this, and we can see
Mhm.
that the way that it's given doesn't have it like it's not an ion, right?
Mhm.
But if it loses its proton, then it can turn into an ion, like this is the ion.
Mhm.
And then from there you just want something that would cause it to become less of that ion product. So
Mhm.
yeah, so basically like okay, if you chlorinate the CH3 group, that'll make it more like since the chlorine is going to be super electronegative, it'll pull electrons towards itself and it'll make this reaction, it'll basically make this acid more acidic because the like, so the fact that it's acidic in the first place is because the oxygens are very electronegative, right? And they're pulling electron
Mhm.
density towards themselves. And that means that the hydrogen doesn't barely has any electron density. So it's not like doesn't want to be next to those oxygens. So it wants to leave. Now, if we chlorinated the methyl group, like if we added a chlorine here, it would make this more acidic because it's chlorine is even more electronegative than oxygen, so it makes that proton more likely to leave. So that won't
Mhm.
work. Um, and then if you dilute the solution, that means that this, like, let's say we start off at 1 molar acetic acid, we would
Mhm.
increase that concentration, right? If you dilute.
Yeah.
So now if we, oh, let me get rid of this. So
Basically increasing the concentration of the actual acetic acid to separate into ions. So basically pushing it to the right. Right.
uh
Yeah.
yeah.
Okay.
And then,
because that's adding more H2O to be like H plus. Yeah, yeah,
yep, yep. And then this one, adding a drop of basic indicator. So this is another example of weird wording on their part. For
yeah.
us, what's important here is the word basic, not really the word indicator, not really the word drop or anything like that, but the word basic, because a base would want to be protonated, right?
Mhm.
So if we added a base, it would use up the protons here, right?
Mhm.
And if you use this up, then we don't have as much protons left because they get used up, right?
Mhm.
And that means that this reaction will shift forward, right?
Yeah.
So that's why we don't want to add any base to it. But then,
So it wait. If we add a base, it would do what to it again? Can you say that again? It would use it up.
oh yeah.
It
So
would use.
for instance, like let's say that I add like NaOH to give me OH like a hydroxide ion, right?
Mhm.
And so the hydroxide ion, if it's a base, it wants to accept protons, right?
Sometimes, yeah, which makes it.
Yeah, so like this H plus is going to be given to the OH minus to make like H2O, and that means that we have a drop in the amount of H plus.
Mhm.
And if we have a drop in the amount of, a product, the reaction has to shift forward, right?
Yeah.
And so adding a drop of basic indicator is basically just saying adding a base. And we know
Mhm.
that adding a base will use up the protons, and that means that the reaction is going to shift forward, right?
Yeah. Yeah.
But now, if we look at C, and this could also be like a nice strategy, if you see two choices that are the opposite like this, right?
Pick the other one. Yep, I know that one.
Yeah, so now that's just like an additional strategy. I still want you to be able to like, explain to me like why these answers are right, but like adding HCl, right? Let's see. So HCl turns into H plus and Cl minus. But now if we add that to this acetic acid, this amount of H plus goes up, right?
Mhm.
And then that becomes too much of a product.
Uh huh.
And so
So that really shift.
yep, it'll have to then shift to the left.
Okay.
Hmm.
All righty.
Yeah, so that one mostly to make sure that we understand what the question's asking, and a lot of times it'll fit in with some common themes that you'll see on the test, and Le Chatelier's principle is a very common theme that you'll see on the test. Yeah. Okay. Now this one, so this is a good topic to talk about a bit because they like to
So
test.
we talked about it.
Yeah,
We both talked about it already. Remember, because
yeah,
I was like, I'm struggling with lights and everything, and we talked about like what energy means and a photon and how it's emitted and
yeah,
the thing. So like when it came to this question and I was looking at it, I what had happened, I hadn't recalled the intensity because there was something different with intensity when
yeah.
like I thought like when it came to intensity, something was different with the photons that was emitted. So I was like, oh, okay, so we're dealing with um something else rather than just picking photons emitted. Because we talked about how like energy
Hmm.
and frequency is like we talked about how energy and frequency is like
Yep.
different, and when they said something about intensity, there's something else that's different. So I just remembered that, and then that's why I ended up picking B instead of D
Got
when
it.
I would have originally picked D.
Yeah, yeah. Now, so yeah, when we talked about this, one of the biggest things um that we talked about was how intensity is not energy, and that they like
Oh.
to try to trick you into thinking intensity is energy, because when you just think of the word intense, it sounds like, in energy, right? But
Hmm.
yeah, so your energy of your photon is your HF, so it's proportional to the frequency, and that's, hc over lambda, which is inversely proportional to wavelength. But
Hmm.
intensity, so first, most important thing to know is just intensity is not energy.
Hmm.
Okay? Now, what is intensity? It's closer, if we're talking about light, to the number of photons. Okay? And I can go a step beyond that. The intensity, which is like related to the number of photons, if we're talking about light, will correspond to brightness. Okay? And if we're talking about sound, it'll be the number of sound waves, and that'll correspond to loudness.
Okay.
And then one last thing. And then the unit for intensity is going to be power over area. So watts per square meter.
Yeah.
So let's say that in an atom like this, that in order to go from n is equal to 1, like shell, to n is equal to 2, let's say that the energy you need is 1 electron volt. And let me just make sure. So if we shot this atom with photons that have 0.99 electron volts, what will happen?
If you shot it with 0.99 electron volts,
Yes.
it would what? You're asking like how many volts would it like be emitted from it, or like how much it would hit?
Oh, so basically, um, like the energy transition for an
Uh
electron,
huh.
like let's say that for the electron to go from the ground state, n is equal to 1,
Hmm.
to n is
Hmm.
equal to 2, you need 1 electron volts of energy.
Okay, so it costs money to like transfer to for basically cost to transfer state. So if we have 0.99 and we need one from it, then it won't transfer from that ground state to the next.
Correct. And because it's has to be at least exactly 1 electron volt or
Hmm.
higher. But now something that they could ask is, what if we shot 2 photons with 0.99 electron volts?
2 photons
Yeah.
for 0.99. So then we'll be able to like what get one. We shot one. It only costs one, so one would be emitted, and the other one would be like taken away. I guess is how you describe it when
So
one would rain in ground state.
so now this is the thing though. So
Uh huh.
this is in quantum mechanics, right? It's called that because
Mhm.
you need exact amounts. Like meaning if you need 1 electron volt to absorb the photon and excite the electron,
Mhm.
0.99 electron volts, like photons with that energy, is not going to be enough.
Enough for it to transition, even though it's more than one.
Um, so meaning more than 1 photon, you're saying?
Yeah, like more than one. Like two, because you said it was two, what, volts is what you said, or two photons?
Oh, two photons.
Okay, yeah. So because they're all both of them equal, only 0.99 is still not enough for any of them to move from one to the next.
Good. Now, what if you had like 10 trillion of these photons with 0.99 electron volts of energy?
It still wouldn't be enough.
Good. So now, if you think about it, right, what we're saying
Hmm.
is you have one photon with 0.99 electron volts, or if you have two, the only thing that changes is the number of photons, right?
Hmm.
AKA the intensity.
Okay.
But the energy isn't changing, and it doesn't matter if you have, if your photon does not have enough energy, it doesn't matter how many of those photons you have. Because if you have more photons, you could have a higher intensity, but you don't have a higher energy. The energy and intensity are distinct.
Okay.
Mhm.
Yeah. So I just remembered like a negative, and I was like, okay, so it has nothing to do with the photons, and it ended up picking wavelength of radiation.
Mm.
So that's how I ended up approaching that. Just
Mhm.
like basically my thing, not applying the content that I like had learned correctly when it comes to questions.
Yeah. So for this one, I would say that the
Oh,
intensity,
I bet.
yeah, the intensity concept it was like a content thing. So just make sure that you um understand that that
Understand that.
is not energy. And then also, if you shot like more than one photon with 0.99 electron volts, understand that they don't add up like that.
So like if you shoot the volts, that means that it's not being emitted because it isn't enough when we think of it as far as like photons. It doesn't end up getting emitted to shown because it's not enough to transition from its ground state to be emitted, correct?
Yeah, so basically,
Okay.
yeah. So the energy,
Okay.
yeah, the energy level difference in the atom from the ground state to the excited state must be equal to at least like greater than or equal to the energy of that photon. And if it's enough energy, if the photon has enough energy, then the photon can get absorbed by the atom, and the atom can express that by exciting an electron to its from its ground state to an excited state. Um, and eventually, when it goes back, the electron goes back down to its ground state, it'll emit a photon of the same energy.
Oh, okay.
Mhm.
All right. Thank you.
Yeah. And this one, let's see.
Oh yeah, this one.
Mhm.
Oh yeah, this one made me upset.
Yeah.
This one made me upset because I just like I looked at this one and then just stopped reviewing at that point because when I was answering the questions, I ended up getting the equation right, which was the question before
Okay.
or the question after, but I ended up not doing the math correctly.
Okay. Got it.
So, what is the percent atmospheric pressure is the pulse pressure of a human adult?
Hmm. Okay. So, because we do have to wrap up, but this is what I would say for you to do, like for this test, basically. Look at, so like, you know how we did this in terms of like filtering it by incorrect? So do that. And then for each of these questions, like as you review them, write down like what the question is asking, and then like think about that related to what you thought the question was asking, and then choose and then write down like, okay, like based on like, so for like that one problem with whatever, the acetic acid, you can write down like, okay, I thought it was asking for maybe a change in the concentration or something that they were giving. And like if they're saying to make a lower percent ionization of a 1 molar concentration of acetic acid, you can write down, okay, I thought that they were asking to make it less concentrated, and that's why I chose diluting it. And then you can,
Mhm.
what the question was really trying to ask is how do we make this reaction that if it moves forward causes ionization, how can we make it move backwards?
Okay.
So I would say to go through like these, like when you do the filtering like this, it can make it like faster for you to be able to
Mhm.
do these, and then just um yeah, just write down in your like review like what you thought the
Mhm.
question was asking, and that's why you chose the answer versus
Mhm.
the question is really asking, and then what the answer would be in that case. So
Okay.
I think that's good that because it's yeah, I think it shows that you have a pretty good understanding from what I've seen, but let's look into like making sure that we understand what it's asking us.
Okay.
Yeah.
Okay, I'll do that. I'll finish it up and do that and do some content review with like UWorld on the different content
Yep.
sections that we have.
Yep.
And I'll try to get as much as I can in. But for right now,
Yep.
I don't know. I'm just doing at this point.
I think we're on the right track. So now we know that it's large, at least from what I've seen so far. Just has to do with the MCAT asking questions that are not very straightforward, and your understanding of it, like if your understanding of it was right, then your answer
Hmm.
would make logical sense. But I think it's just that they're asking things in really weird ways.
Okay, but real quick before you head out,
Yep.
so when do you think that because I'm starting boot camp actually today. When do you think that we will do the transition for me to start answering AMC once my Altius is done?
Um, let's see. Because in the boot camp, do they have you like take like the AMC test like part of the course?
Yes, but it doesn't start off like that. It starts off with you doing AMC like questions like the CP
Yeah.
question bank volume 1.3. Yeah, it starts off with that. But they also accompany it with UWorld.
Yeah.
So like I pushed it back so I could just do content and what we were doing.
Yeah.
But now I like because since content is still like one of like the things that I'm not getting, I'm gonna still
Yep.
do like the content. You just want me to skip the U World question banks that they have. Tell me to answer.
Oh no, you can follow like the curriculum that they gave you in the
Okay.
yeah. Um and yeah, if they tell you to do like AMC stuff, you can do AMC stuff. If they tell you to do UWorld stuff, do the UWorld stuff that they assigned you. Um
Mhm.
and then tell me, I guess, when you started and stuff, like what the like test schedule is that they give you, like on which days you take which tests.
Mhm.
That you can figure out like if we want to like adhere to that or if we want to take
Okay.
tests outside of that. Yeah.
Okay. I'll just email you the schedule that they would want.
Yes. All right.
All right. Thank you so much.
Yeah, of course. Yeah, I
You
think
have a good.
doing well. Yep. You too. All right.
You have a good day. Thank you so much.
All right. Take care.